This is a Panasonic outdoor PCB, and it's completely dead. It's not turning on at all, and I'll explain the situation that caused this. What happened is that when the customer had it installed, the electrical polarity was connected incorrectly by a technician. Due to this incorrect polarity, the PCB stopped working within a week, and now there's a problem with it. I've identified part of the issue, but I will explain the troubleshooting method step by step. This typically happens when there's no short circuit in the PCB and no other major problem, especially when the high side is completely fine. So we begin the testing process. First, we check the main fuse, then tested all 3 capacitors, and they are perfectly fine with no issues. The next step is to test the IPM, Intelligent Power Module, and the IGBT, along with the 2 bridge rectifiers, to ensure there are no problems with them. If all these components are fine and the multimeter shows them as okay, then the next stage of testing is the SMPS. If the SMPS circuit is working, the PCB should function. If there's a problem, it could cause further issues. The first thing I did was replace the STR IC, which is a switching-based IC. This is often the solution to the problem, but the switching IC was perfectly fine. Its model number is STR V152, and it was installed on the board. I replaced it, but nothing changed, and the same problem persisted. Sometimes this technique works, but when it doesn't, it's necessary to do a complete and proper testing of the board. I have taken all the necessary safety precautions. I've secured the UVW connections coming from the IPM, as well as the earthing wires. Now, this PCB will be attached to its reactor along with the wires. Here, there's an IC with pins numbered from 1 to 8. And this is the switching IC. The system switches from here and moves forward into the chopper circuit. This pin leads to the feedback section where there is an optocoupler located below. Now, we need to check whether the switching is happening or not. For that, the voltage positions are marked here. The company has provided the voltage values. For testing, 15 volts should be checked in one position and 13 volts in another. To perform this test, electricity will be applied, but we need to ensure that the electrical polarity is properly connected so that we don't encounter any issues during the testing. Now, we checked the voltages at this point, but there are no voltages showing. After checking, we found no voltage at all. However, when we tested the capacitor, it showed 9.25 volts. After this, we moved to the 15-volt point. We connected the positive lead here and the negative lead there, and we found that voltage was being generated, sometimes 14, sometimes 15 volts, with some fluctuation in the reading. At this point, we are receiving low voltage. Now, the main drive system, which powers the microcontroller, is located here. There's a 5-volt voltage regulator, and we will check it from this side. Since we are getting 9 volts, we need to test for 8 volts here. So, we will place the positive probe on the 8-volt position and the other side on the ground. As you can see, there are no 8 volts coming through, only some millivolts reaching this point. We will check the top side as well, where the positions are clearly marked. I stands for input, the center is ground, and the other is output. First, we'll check the input. Although we've already tested it, we'll check again to confirm. There is no voltage present at the input, and as expected, there's no voltage at the output either. This means that the 8 volts are missing from one of these positions. Now, regarding the diodes and resistors installed on the board, after testing them, I first turned off the power. Then I discharged the capacitors. Looking here, the issue seems to be with the low side windings of the chopper. As you can see, there are pins 1, 2, 3, and 4, and if you look at the 4th pin, you can see a diode installed here. There is another diode installed next to it. On the other side, if you observe, there are 2 diodes, labeled diode 24 and diode 22. These diodes are important because they are connected to the auxiliary windings, which create low voltages. Now, I'll take the multimeter and switch it to diode mode. Checking diode D22, it shows that it is perfectly fine. We'll check its reverse polarity to ensure there's no leakage, and it shows correct readings from both sides. However, this kind of result sometimes happens in the system. Next, we'll check the other diode, D24. When we check D24, it shows 0, indicating that it is short-circuited. I'll change the polarity and check again, but even after switching polarity, the reading remains the same. In this case, the voltage regulator is not functioning because of the shorted diode. Now, I'll remove this diode from the board. The diode has been desoldered and taken out. As you can see, it still shows 0, meaning it's completely dead. The PCB is now fully functional with no remaining issues. However, before explaining what I did, I'll first test it. I'll apply power to the PCB, and you can hear the switching sound. Now we heard the switching sound, which means the PCB is now on. The only issue was in the SMPS, and I've fixed that. Let me explain what I did. First, I'll turn off the PCB. Now, as you can see, I replaced the diode at the D24 position, but the new diode is much larger than the one originally installed. The previous diode was smaller, so let's check its part number. The original diode was labeled 1.Z67, which is a fast recovery diode. I replaced it with an FR107, which is also a fast recovery diode, and I installed it in place of the old one. Additionally, the problem was also in the voltage regulator. The old voltage regulator was the one originally installed by the company, so I removed it and replaced it with a new one. Now, the PCB is back to its original condition and is working perfectly. At the moment, it's functioning flawlessly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.